Okay, here we go. So tell me. So, you guys know your limit definition of a derivative. So we're doing calculus with all these things here. Limit definition of a derivative, find the first derivatives, you know, like f of x plus h minus f of x, that thing over h. All right, what does the first derivative tell you about a curve? Rate of change, the slope of the tangent line, the velocity. What does the second derivative tell you about a curve? Acceleration, alright. Acceleration, 1 out? Yeah. I don't know. Alright, the equation of a tangent line. So when you do the equation of a tangent line, you need the slope of the tangent line, which is the first derivative coming from that, right? And you also need the points where you're doing it from, so there could be that. All right, so if somebody asks for an equation of a tangent line, you need a point and like a slope vector in a way. All right, an indefinite integral. Indefinite means there's numbers on it or not? No. So indefinite integral is when you have something with no numbers and you will be doing dt, you get something there. So you can put your answer, you can put plus c on it, right? And a definite integral has numbers, but, you know, it has the numbers on it, a and b, so you get like an answer, like a number answer, right? And these things, like last year in calculus, an integral told you the what on a picture? Area under the curve, right? Area under the curve. All right, and later when we do it in 3D, in 3D, an area turns into a volume in a way. Okay, all right, so you learn all those things in calculus class, so just remember those things. So like later, when somebody does this to you and they say, oh, find me, we're going to do something called curvature. It's like the amount that a curve is curving at a certain time. All right, so if I ask you to find the maximum curvature, what process in calculus do you use to find the maximum of a function? You take the first derivative and set it equal to 0, right? So if you want to find the maximum curvature, when you have the curvature equation, you take its derivative and then set it equal to 0, right? Oh, yeah. All right. So here, so this is our limit definition of the derivative of our vector function. And so we're not going to do the limit definition here. So we're just going to do the derivatives, all right? But realize what that's doing. This black curve is the curve here. You're going to notice there's r prime and t right there. So it's like the slope, it's like the direction of the tangent vector, right? Okay? And later you're going to learn that there's another vector sticking out here called the normal vector, like a perpendicular. But I mean, you don't have to do that yet. I'm just kind of like previewing, okay? So just like before, this calculation, you use the slope of secant lines, and it kind of like, you know, focuses in, because h is going to 0, it focuses in, and then she becomes a tangent line. Like last year when you were learning about this, you learned that you were doing the slope from P to Q, but then Q is getting closer and closer to P, and then that's why it was becoming a tangent line. All right, so whatever. Anyway, so if you have R of t is 3 separate functions, like you've been seeing in your problem, then R prime of t is just simply f prime of t, and then g prime of t. So, you know, you just do the derivative of each part, just like last time you did the limit of each part, and h prime of t. All right. So, also you can write it with I, J, and K, right? All right. So, when you're doing the derivative, you're finding basically the tangent vector, right? So this is also the tangent vector. All right, also called that. And so what we're going to also need to do is to find the unit tangent vector. So if I want a unit vector of a vector, what do I have to get rid of? I have to divide it by its own magnitude, right? So when somebody puts this big T right here, that means unit tangent vector, the big T with the little t there, all right? So that means you need to take the derivative, which is r prime of t, so r prime of t, so take the slope vector, the tangent vector, and divide it by its own magnitude. So down here I do the magnitude of r prime of t. So that's a big deal to learn that here, because next section when we need that, you got to be like, oh, I know that. Okay? All right, so let me fill in this thing. So we'll also be using the unit tangent vector, which remember is a vector having the same direction, right? Right, there's only 1 unit long. So when you have a vector that's the same direction, you can take it around and use it to like model other things after it, but then it's not affecting the strength of it because it's only like 1 unit. You multiply by 1, you get the same thing. All right, so let's practice here. Moving right along. So, I do not like this, IJK business. Like me personally, when I do my stuff, I'm just going to use those arrow brackets. What a equal sign, I don't know. All right. So I'm just going to do r prime of t, and I'm going to put these brackets here, right? So what's the derivative of 1 plus t to the third? 3t squared. Comma, oh shoot. That middle part's going to need what? Okay, I want the answers, Brainiac. All right, I just want to tell me what it's going to be. What's like the process? Okay, like product rule, basically, my overall thing. So let's skip that for a minute. What's my derivative of sine 2t? Okay, the derivative of sine is cosine, so cosine 2t, and then derivative of 2t would be the 2, right? So 2 cosine 2t. All right, I'm going to do that middle part. Should I put a plus c? Oh, some of you think I should, I thought, because y'all were putting on your derivatives around the room. Right, that's for integrals, right, okay. All right, so let's do that first part. So let's do that out here so we can kind of write the cleaned up version there. So I know you all, it's like when I do it, I always just do the derivative of the first part, and then I multiply by the second part. But for some reason, you guys do the derivative of the second part first, right? I don't know, like I feel like y'all, you sing that song or whatever, and you're just like, okay. So I'm going to do it my way, but, it doesn't matter because we're adding them anyway, so you can interchange the order. So me personally, I'm like, okay, derivative of t is what? 1 times, leave e to the negative t alone. Then I'm going to leave t alone, so that's still there, but what's the derivative of e to the negative t? Correct. We're going to e to the negative t is e to the negative t again, but times the derivative of negative t, which is negative 1. All right? So if I clean that up, I'll get e to the negative t. That'll be a minus t e to the negative t. So I'll go with that. Okay. All right. So it says, letter B, find the unit tangent vector where t equals 0. All right? So this is a place where things can get really hairy if you don't recognize that you can do something. They gave you a number. If I wanted the unit tangent vector and nobody gave me a number, I would have to do the magnitude of these expressions. I'd have to do the square root. I'd have to square each part and write that down. That would be the formula for the unit tangent vector. But you've given me 0. I'm supposed to plug in 0. So what I can do is I can find r prime of 0, and that'll be 3 little nice numbers, and then I can take its magnitude and put it underneath, right? Like I don't want to do all that. Sometimes you have to do the yucky thing because nobody gives you a number. But here we got numbers. So if I plug 0 into 3t squared, what do I get? 0. All right. Over here, e to the 0 is 1, and then I got 0 times e to the 0, so it's just going to be 1 minus nothing. 1. All right, and in the back, be careful. Cosine of 0 is 1, so 2 times 1 is 2. All right, so I'm looking for my unit tangent vector at 0. That's what I'm finding right here. Alright, so basically I'm going to take this vector, 0, 1, and 2, and divide it by its own magnitude. So what's the magnitude of that? Now what number should go in my radical? 5. 5, yes. Alright, and we can leave it like that technically, but let's just go ahead and write it. 0 over radical 5 is 0, then I get 1 over radical 5, and 2 over radical 5. Like the only kind of reduction that I personally don't care about is like, you don't have to rationalize in the denominator, okay? Like just leave it. Okay, good? So you could write this in IJK form if you really wanted to. Okay. So you find me on this next one. I want you to find me r prime of t, and let's put it in this vector format again. So you find me r prime of t right here. Ooh, but it's only 2 parts. So let's not put the third because we're going to sketch it like in 2 dimensions. Alright, so we got 1/2 t to the what? Negative 1/2. So 1/2 t to the negative 1/2 for my derivative of radical t, and the other one would just be negative 1. Yeah, so we're just gonna leave the k off because I'm gonna sketch it over here. So we're gonna sketch the position vector, and we're gonna do like x and y. Like we're gonna leave the z part out of it for now. Okay. All right. So first of all, let's go ahead and sketch the actual curve. So let me get some points going over here. So like, what if I plug in like 0 into my curve? What do I get? 0 and 2.
Oh, for r?
For r, just r, yeah. So 0 and 2. Everybody go with that? So that's a vector that starts me here. It puts me up at 2. Everybody good? So I kind of got like a point here. I'm trying to like see where it's going. So yes, it's this vector from the origin up here, but like where does it go next? And it's going to follow that path. So let's try to plug in, I don't know, like 1/2. So what's the square root of 1/2? Did you just say 1/4? I'll do it myself. Don't bother yourselves. The square root of 0.5 is 0.71. All right, and then 2 minus 1/2 is 1.5. Yes, you guys are sharp. All right. All right, so let's do this one. So 0.71 and 1.5. So, if I put like a 1 here, a 1 and a 2, so 0.71 and 1.5, like about like there. Okay, so then let's put in like 1 or something. So if I do r of 1, what's the square root of 1? 1. And I get 1, 1. All right, so 1, 1 would be like right there. So, and lastly, let's go ahead and put in like 2. The square root of 2 is 1 point, you don't know that one? 1.41? So r of 2, 1.4. And if I put a 2 in there, 2 minus 2 is 0. So it comes there. So you see, as you're traveling, as you're using this vector for bigger values of t, you're basically like traveling like that. All right, and put some arrows on it. And you're like, hey, I'm going like that. Okay, we'll stop here. All right. So I am trying to draw the position vector r of 1. So when I plugged in 1, I got this point right here. So my position vector for R1 would be, change my color a little bit, would be a vector, I have to draw the vector 1, 1. So that would be me coming from here and going to there. So that would be like R1. That would be my position vector at when t is 1. Okay. All right. So then I have to draw the derivative of 1. So r prime of 1. So let's plug 1 into this problem we just got. The negative 1 will not change. All right. And what if I plug 1 in, what's this 1 over the square root of 1? for the t part, 1. So basically I just get 1/2, right? So remember, my derivative vector is like the slope of the tangent line. And so you're traveling down, right? Right? So what's happening here is then that, ooh, crap. All right? So at this point right here, I draw that vector. So I go to the right 1/2 and like down 1. So you see how that tangent vector is like that? So that would be like r prime of 1. From here, because it's supposed to be tangent at this point, I go to the right 1/2, down 1. I mean, I know my graph sucks, but like, you get it? So that should be the tangent line. Good? Hold on. So from this point, I'm doing the 1/2 -1. I'm going right 1/2 and then down 1. So, you know, your vector numbers are like your x and your y values from where you start. Okay, good? Did I get the physics correct? I guess, I don't know, whatever. All right, so there we go. So you can see how it kind of like lines up. All right, next page. I'm trying to go fast. I only got like 15 minutes left. Or you guys have to leave. All right. So find the parametric equations. So x, y, z are parametric equations for the tangent line to the helix with this parametric equations. All right. So I want the equation. Basically, I want the equation of the tangent line. That's what somebody's telling me. Equation of the tangent line. So I need a tangent line. So I'm going to use the equation of a line that I had before. For an equation of a line, I need a direction vector like an ABC. That's going to be my tangent vector. That's going to be my derivative, r prime of t, right? I need that. And I also need a point on the line. All right? So, what point have you been given that you want this to happen at? 0, 1, 2. 0, 1, and pi over 2. Now, you don't recognize it, but this is very sneaky here. At some point, you're going to want a value for t to plug into this to get the direction vector. All right? So can you look at this? This point is on this curve. So can you tell me what value of t have you secretly been told that you're at right now? Do you see it? Z is t, so this right here. Right? So when you're at that point, your t value is pi over 2. It's like a little sneaky way, like nobody said t is pi over 2, but you've actually been told it and you just don't realize it. So this curve is this picture over here. If you go to pi over 2, then t is pi. When t is pi over 2, that's that point right there. So it's sneaky, but you've been told that t is pi over 2. So when I find the derivative, when I find the tangent vector, I'm going to plug pi over 2 into it because that's the t value of where I'm at. See? But nobody's going to explicitly say to you, t is pi over 2. But you have been told. All right, so here we go. So I need my r prime of t. So I'm just finding the derivative. So what's the derivative of 2 cosine? Negative 2 sine, right? What's the derivative of sine? Cosine. And derivative of t is just 1. All right, so now I need to plug in pi over 2. So r prime of pi over 2. What's the coordinate at pi over 2? What's on the unit circle? What's the coordinate on the unit circle? 0, 1. So the cosine 0, the sine is 1. So sine is 1, so that makes it negative 2. Cosine 0, and then I have a 1 on the end. All right, so here's my derivative. This derivative is basically my tangent vector, right? Is my direction vector of a line, of a parametric equation line that I'm going to write. And then the point that I'm going to use is over there. So remember, so I got x equals, y equals, and z equals. It's equation of a line like on your test, right? So I take my direction, negative 2, put a t with it, and then I add the coordinate of the point for x. So what's the x value of the point that I'm at? 0. So I mean, I wouldn't usually write 0, but just I already wrote it, so whatever. All right, the y value. The y value for t is 0. So 0t plus, what's the y value of the point on that? 1. And then the z is 1, so 1t plus pi over 2. All right, so obviously I would write x equals negative 2t. Remember, this is a parametric equation of the tangent line. So this is the tangent line. C 1 and z would be t plus pi over 2. All right, we're good? So like an equation line you've seen before. All right, and just to, let's just skip this. If you had to do the second derivative, you could just do the second derivative. Don't worry about it. All right. Okay, where's my little clicker? Here we go. All right, you try it. Find me the unit tangent vector. So this time I didn't give you a number. So you're going to need r prime of t, and you're going to need the magnitude of r prime of t. So you need those two items to do this. I'm wrong. All right, we good with these basic facts right here?
Isn't it supposed to be like 16 over t squared?
Yes. I was just seeing if you're paying attention. Thank you. All right, I have it on my paper, correct? That's what I get for not looking. All right, we good? Thank you. All right, so of course you could kind of stop here, but you know the book is going to sometimes like clean things up a little bit. So let's work on this magnitude here for a second. Okay. So let me try to get under this radical. Let me try to get everything with a t squared. So if I could, because the square root of t squared is just t. Because you would look at the answer in the back of the book, and it's not going to be this over this. And you'll be like, I got it wrong, or whatever. Like, you can do some stuff to it. So if I did that here, if I'm going to give a t squared to both of these items, it'll be 4t to the fourth. Is that okay? I'm giving a t squared to the bottom of the 4t squared. So that would become 4t to the fourth plus, I'm giving a t squared to the bottom of the 16, so 16t squared plus 16. Does everybody follow that? Algebra 2?
Yes. Yeah.
Okay. All right. So what do you notice? I'm still inside my radical. Everything on top is divisible by 4. So could I just put my 4 over t squared out here, and what would be left? So I know I'm gonna do it. But like, if I take the 4 and the t squared out front, what's left on top for here? T to the fourth plus. Guys, I'm dividing the top by 4 and pulling it out. The t squared, I just wrote it in front.
4t squared.
Right, so take the 4 out, so t to the fourth, this would be 4t squared plus 4. All right, do you recognize that this factors? If you split up t to the fourth evenly, it'll be t squared. So t squared, both plus 2, you follow? Okay, so inside that radical is a square root. We got 4. We got t squared plus 2 twice. T squared plus 2 squared and a t squared on the bottom. So if I were to go over here and write my equation for my magnitude, I could clean it up to what? Because I can do the square root of all those things. 2 t squared plus 2 comes out, and on the bottom a t. All right? So it cleans up. I'm not saying that you always have to clean it up. Check it out a little bit. Maybe there's some algebra to do. So I'm going to take for my unit tangent vector, I'm going to take the original vector, 2t, 4, and 4 over t, and I'm going to put over it 2t squared plus 2 over t. So if I kind of clean that up a little bit, basically I'm getting like 3 fractions. I'm getting 2t divided by this. So times t over 2 and t squared plus 2. Is that good? So 2t divided by that, the bottom flips up and multiplies. So what can I write? Am I blowing your mind or what? This divided by that. So I could write t squared over t squared plus 2. That's the first part. So let's imagine the next part. So the next part would be 4 times this flips up, t over 2 and then t squared plus 2. So that would just turn into 2t on top. 2t and t squared plus 2. And then the last one, I would have 4 over t times t over 2 and then t squared plus 2. So this cancels out to 2 and the t's go away. So I got 2 over t squared plus 2. So that would be what the back of the book is going to say your unit tangent vector is, because they like to clean it up. Okay? So if I wanted you to clean it up, I guess I would tell you to clean it up, but that's a little algebra you can do there. Okay. All right. So I'm going to skip over these little rules right here. Maybe we'll do them one day, maybe we won't. But basically, there's all these little rules for, like, if you are doing the derivative of something added, well, you can do the derivative of each one and add them together, basically. So you could add them first and then do the derivative, or you could like kind of do like distributive property. You see that? If you're doing the derivative of, 2 functions here, basically it's like, this looks like what rule to you? Product rule, right? The derivative of product, like product rule. Now, cross product is really bad, all right? So you're doing the derivative of a cross product, and you don't want to do the cross product first, and just do the derivative, then you could basically, kind of like product rule again. You do the cross product with the derivative of one of them, and then the cross product with the derivative of the other one, all right? These are all just little rules, like anybody would just like look them up if they really wanted to do them. So let's just write this one down, and we're going to skip the 2 examples on it, and I'll take them off your homework there. All right, what is this one? The dot product rule. So if you want the derivative of a dot product, you could do the derivative. Oh, let me just write it the derivative way. You do the derivative like u prime of t, dotted with vt, plus, then you would do basically leave u alone, dot with v prime of t. That's a prime right there. So it's kind of like product rule in a way, but that's called the dot product rule. So remember, this dot means a dot product, not multiplication like earlier. All right, so let's skip over these next 2 things. And like I said, I'll take them off. They're just like very, what I'll do is I'll go write them in there later, and you can like look at the notes and stuff if you're like super interested, but it's fine. We can skip over it. All right, so let's do our last one, right? Is this the last one? Is it? Okay. So if you're doing an integral, the integral of a thing, I should have put a dt right here. Okay? You guys can go if you need to and write this down later, but just review the integral. That's it. All right, and also look for, I'm going to put on Schoology. I'm going to cut 1 or 2 of these off because they're a little ones. Okay? I'll put the list in today's folder of the problems. All right, so here we go. So basically, the integral of a function is it's going to be the integral. Oh my God. when I get in its way. I'm basically going to just be doing the integral from A to B of the x part, of the f part. F of t. So it's like you're doing 3 integrals in one, I guess. All right, then you got the integral of the, what's the next one, g of t. And then the last one is h, integral h. Okay, so it's just like doing 3 problems in one. And if somebody, you know, the fundamental theorem of calculus, if somebody puts numbers there, you know, you're plugging in the number to the top number at first minus the bottom number, right? Okay, so let's do one down here. So now be careful with all of your little what's it called? Your plugins, I guess. So we're trying to do the integral from 0 to pi over 2 of 2 cosine t, comma sine t, comma 2t. Is that okay? That's what we're doing. If I write it like in vector little arrow form.
I see this.
All right, all, you know, very simple integrals. So let's do the integrals first. So we'll do our plug-in later. So what's the integral of cosine? Negative sine. So it'll be -2 with the sine. Integral of sine is, no, wait a minute. There's no negative on this. Integral of cosine is just sine, right? Integral of sine is negative cosine. And then integral of 2t. 2t squared over 2, so just t squared. Very good. So you're not going to see integrals that are like super hard all the time, because the hard part is realizing that you got to do 3 of them, and you know, like they're not that bad. So anyway, we got to evaluate this from 0 to pi over 2. So what's the coordinate at pi over 2 on the unit circle?
0, 1.
0, 1. What's the coordinate at 0? 1, 0. So there's my cosine and my sine, you know, so think about those. All right, so let's plug in pi over 2. So we get a vector. So the sine of pi over 2 is 1, so 2 times 1 will be 2. Negative cosine at pi over 2 is 0, so 0. And then that'll be, I'm plugging in pi over 2, so pi over 2 squared. So I'll put pi squared over 4. Okay, good with that? So that's me plugging pi over 2 in for all those t's. All right, minus another vector with some other numbers, the sine plugging in 0. So sine of 0 is 0, so that's 0. Cosine of 0, though, is 1, so it'll be -1. And then 0 squared is 0. All right, so I'm just giving a problem or an answer that is the subtraction of these 2 things. So 2 minus 0 is 2. 0 minus -1 is 1. And the last one is just pi squared over 4. Okay, so it's not that bad, it's just you gotta do 3 of it. All right, give me a second to knock off a couple of those problems. Let me just check and see which.
I'm gonna try your.
You know, there's surrounding area well, I mean, but no, it's not. No. I'm not how you use that. Usually,
What?
The great thing about how you are such a hypocrite to even say that. Didn't even know I could do this. Oh, I can get out on Monday? Oh, wait, oh, no. Monday is, okay. What returns do you have? Like 6.5? What?
I know this. Hold on. Hold on. I actually. This is the business. It's the business. No.
That's already not on there.
You know my I know my Ellen. I guess I have a couple credits earlier. I think mine is no one absolute value. That's my Ellen.
Alright. Hang on, I'm having a hard time deciding. I know, I'm trying, but like, I just love them all.
You're not sure anything else.
No.
I never said it was so easy, so I don't know where you're at.
All right. 37. All right, there you go. That's all I can put.
What is the integral of a y times x or x? Ln x minus x. That's pretty much
I want to say. Make sure. That's something else. That's like a. That's something else to do later. I was thinking of. Yeah, I was like, you just added. You did. Right. Because the area under a curve. So I have to look. I don't think it's like the area of like the sheet coming down, because that's something later I want to watch. But I'll see. I mean, a lot of times you're doing, somebody gives you the derivative and you do the integral to get the original. That's kind of what you're doing. Let's see. Let's see what Google says. All right.